Good morning. My name is Eva, and I'm from the marketing team. I'm pleased to introduce Jonny Cheetham, that is with us this morning to actually present you the Neo4j Top Use Cases. If you have any questions, just put them in the question panel, and we will answer them at the end. Thank you. Jonny?
Good morning, everybody. My name's Jonny Cheetham. I'm part of the commercial team here at Neo in London. We're going to be joined by Jesus Barassa, who's a sales engineer who can answer any technical questions that you've got about the structure of the product towards the end. So thanks very much for logging in. What we're going to do today is talk about some of the ways in which a graph database can help you, and in particular why you would want to use a graph database. So I'll start this morning. That's just me and Jesus. I'll start this morning just with a quick tour of what great databases there are out there. And the greatest of them all, of course, and maybe some of you have guessed this, is a database which has got something like 200 to 300 trillion connections in it. If you look in detail inside, you'll see that it's made of things called neurons and things called synapses. The synapses are those connecting things. And if your brain's in good shape, you'll have 200 or 300 trillion of those at the least. And if you're an Einstein level person, it'll be a lot more than that, because it's the connections in your brain that are the things that make it function and differentiate super intelligent people from the rest of us. So if you look at that, it doesn't look much like a database, but it really is a database because it's storing information and it's providing ways of processing information. But that's just one example of the sort of network that we're seeing everywhere. And I guess another one is the medium we're using for this talk this morning. The internet is, of course, a database of sorts. This one's quite small compared to the brain in that it only has about 80 million servers connected to it, but each of those servers obviously can be immensely complicated inside. So it's still a very important network. And if you look at that pattern of branches and leaves, that's very typical of organizational structures that we see all over the natural and indeed the built world. And we'll see it again in the next illustration, which is an illustration here of ancestry of corn. This picture is taken from an illustration, is taken from a talk that's given by one of our customers, the agrochemical company Monsanto, who were using various databases to model the changes of the genetic structure and the characteristics that are associated with that genetic structure of maize or corn. They needed to do very intense modeling over many generations, and they came to graph databases because their initial attempts at doing this using relational databases ran out of steam when they got to 8 or 9 generations. And one of the characteristics that they noticed using a graph database is that it doesn't matter how many generations you use, doesn't matter how many entries, how many points you've got in your database. It just doesn't run out of steam in the same way, and we'll look a little bit at why that might be. Another great database is within the internet, and this illustrates that 80 million server profile of the internet is really only beginning to scratch the surface of the complexity of it. This is just one application running on the internet, and in fact this is just one person's profile. If you look in the middle, you may see the name of one of Neo's engineers, Philip Rappel, and this is his mapping of his own LinkedIn profile, and you can see the little clusters are different places where he's worked or went to college or whatever. And one thing you might notice about this is that the connections between it are extremely rich and meshed. By no way could you describe this as a hierarchy or implement this as a hierarchy. It's a very complex interlinked profile. So if we think about those sorts of data and just about any other sort of data that you're familiar with, you'll realize that the world has come a long way since the relational databases were developed in the 1970s. In the 1970s, relational databases were built to deal with a different sort of problem to the problem that we're looking at with the data that's that's everywhere today. It was built to deal with rows and columns of data, or basically data that could be entered through forms on computers. It's taken us a long way. When you think about what the world was like when those first relational databases were developed, that model has stood up remarkably well. But it's not great for everything, and it's in some senses reaching the end of the road as the proliferation of data becomes so extreme, and as the different types of data organization become so varied. So it's against that a large variety of NoSQL databases have been developed, and Neo4j is one of them, and it's got particular characteristics as a graph database. So if you think about this typical data organization, that's the sort of thing that we're trying to make it possible to work with, process, get value out of within a Neo4j database. Okay, so that was by way of an introduction. This is like one of those movies where you get to the titles halfway through the film. So let's now look at the agenda for today. What we want to do is just talk about what graphs are, what they're good at, and how to get started. Okay, what are graphs? So if you think about any database, it's a way of representing data. It's not the real world, it's a way of modeling and storing information about the real world. And that's a problem that's existed since computers were invented, and before that, of course, index cards and files and things. And there are lots of ways of representing data. So in a relational database, you see tables, and you see rows, and you see columns. And that's very good for certain things. It's particularly good where data structures don't change very often. It's particularly good where the data points are what you're interested in, much more than you're interested in the relationships between the data points. So as it says here, minimal connectivity between data points. So the way of representing data that we're going to talk about today, the graph database, is just a different structure, just a different way of organizing your data, which is, it's good for some things. It's good particularly where data structures are changing all the time. It's difficult to understand which connections, it's difficult to predict in advance, rather, what connections are going to be important, and it's difficult to process those connections. It's good where you're living in an agile world where requirements develop all the time. And it's particularly good for problems where relationships in the data contribute to meaning and value. You remember when we were looking at the human brain, we saw that the value of the brain, the quality of the brain gets more as you add more relationships, more synapses between the neurons. It's just the same in a lot of problem domains. The more you can exploit relationships, the more value you can derive. So we're now going to talk about Neo4j's particular data model. So it's a graph database, but it's a particular sort of graph database. And we'll start just with the very basic elements that make up the model. So first of all, we have what are called nodes. So a node is a data point. So a node is just any sort of data point, and I often say a node is just a thing. The nodes are connected by relationships, and those relationships can be, you can have as many as you like. They can be self-referential, so a relationship can loop back to a node. You can operate a relationship in any direction, either direction. So that's the basic element of a graph, and Neo has added, in Neo4j you find a couple of very powerful but still very simple enhancements to that model. The first is we've got a concept called a label. So you can label different different types of node so that you can process them differently. You might want to handle, in this example, all the roads or all the traffic lights or all the traffic. But nodes are labels rather are powerful things. You can have as many labels as you like associated with a node, and just because you've assigned a label to a node doesn't mean that that node has to have a lot in common with another node with the same label. and we'll see that in a second. So that's the first element in the description that we've added, the label. And the second one, we've also added labels or types to the relationship. And then we've added what we call properties. So if you see here, we've got a property associated with one of the nodes. In this case, the property is a name, and we've associated a property with one of the relationships. You can have as many properties as you like with a node. You can have as many properties as you like with a relationship. They all follow this straightforward key value structure. And just because two nodes have got the same label, two people might be people, they might have a label of people, but it doesn't mean you need to have the same properties associated with them. So that's the whole of the Neo4j graph model: nodes and relationships, labels and properties. So that's very simple, and we can see it's very simple, but it's very extensible. So it's very easy to add new nodes. It's easy to add new concepts. So we've just added, we've got some people, and we've added a new concept, which is a university. Here's another new concept, which is a place of employment. And you can just go on adding nodes as much as you like, and adding new types of relationships. And that's why we say it's a very suitable for an agile environment, very evolving data model. You can just add new concepts and new nodes dynamically at any time. Now, if you look at this model, you think, well, that's quite rich, it's nice, I can understand it, but it's no big deal. But of course, that is just the way we're using it to describe it. But if you look a little further, you'll see that that little pattern might be one among millions, tens of millions, hundreds of millions, or billions. And what we need from a graph database is the ability to process patterns in billions of nodes connected by billions of relationships. And that's the objective of Neo4j, to be able to handle very large numbers of nodes and relationships, but still maintain the simplicity that we saw from that model. Okay, so what would you use a graph database for? What are they good at? So let's first just look at some of the big ways in which graph databases are being applied in the world. And if you look at these, you'll truly see that the world we live in has been changed significantly in the last 10 or 15 years, and that change has been driven, made possible at least, by the application of graph technology and graph databases. So if you think about the way Google has come to dominate the world, 15 years ago there were a lot of different search engines all competing. Google captured the market because it applied graph thinking to the problem of doing search. In particular, they came up with an algorithm called PageRank, which meant that their ranking of pages was more useful than anybody else's. And that PageRank is a graph algorithm, and they needed to store their data as a graph to be able to do it. So that's, that's obviously an absolutely dominant part of our world today, and that's been made possible by a graph. The same is true of search engines. A few years ago, there were dozens of different job search engines. There still are a few, but LinkedIn is now dominating that market. And again, that's based on graph technology. And the same is true across other industries. Now, only one of these three is using Neo4j, and they're not using Neo4j for their main driving. What they've done is write their own graph databases. What Neo4j is a graph database that's capable of delivering this sort of processing power, this capability, this empowerment, if you like, to companies that don't want to go to the trouble of writing their own graph databases. So Neo4j is an off-the-shelf, supported, tested, engineered product for people who've got applications that need graph databases and perhaps have ambitions to change the world in the way that some of these companies have. So let's look at some of the ways in which people are using Neo4j at the moment. There are a number of different use cases, but having worked for Neo for a couple of years, I can say that the biggest characteristic among the use cases is diversity. we see an extraordinary range of ways in which people can think of applying graphs for, as we say, for pleasure and profit. But let's look at the use cases that are probably the commonest. First of all, real-time recommendations. So if you go to a website, that website has only one thing in mind. It really wants to sell you something. And very often, the thing you think of, you buy from that website, maybe the thing that you went there in the first place for, but it may well be something that's being suggested to you. If you think about a physical store, you go in with one thing in mind, but you're entranced by all the attractive things hanging on racks or displayed on shelves, and you buy something else as well. Amazon's webpage, they're very, very keen that not only do you buy the book that you originally went there for, but you also buy a couple of other books or something else as well. That science is the key to running a successful website, and it's based on recommendations. Recommendations can be very simple. You can just bring up a list of products from the same manufacturer or clothes of the same color or something like that. But to be effective, it needs to be very rich and subtle. For example, you need to consider, for example, natural product pairings. If I buy a TV set, I might also want to buy a extended guarantee for that TV set. If I buy a printer, I'll buy ink for it as well. But those relationships can get much more subtle, and what people do is they mine their data to find the relationships in past buying patterns and use those to make recommendations. But that may be a bit naive in some cases, and often if you look at the way in which users have behaved on your website, either the individual who's got the session that's current at the moment, they may have been looking at other products, and that may give you some clue as to their buying habits, or they may fit a profile. They may be, you may be able to identify that they are in the age bracket 15 to 20, and they're interested in technology, and you might think that they'd be interested in something that somebody of a similar profile would be interested in. So it's a rich mixture of personal preferences, of if you like, product pattern preferences, and also of behavior of people who profiled. I like particularly the guy on the right on the picture. He's a builder. He's bought a bucket and a trowel to build a wall, but I think he's going to the beach. I think he's bought a bucket and a spade, and he's going to spend the afternoon on the beach. Okay, so that's recommendations engines. We've got some very well-known users, biggest of which is probably Walmart, who use Neo4j for driving their website recommendations. Other of the four big US retailers at the moment, the four largest, 3 are using Neo4j. So that's a good use case for a graph. A second good use case is what we call master data management. I should say actually that this is only one of the use cases that use the MDM initials, because we also see a lot of people who are using it for metadata management, which is to say managing all the different data silos in their organization and providing connections between them. But master data management is the process of finding finding the unambiguous copy of a record and of structures about a record in an organization. So in this case, we're looking at an employee tree, but there are numerous examples where this is being used for providing that total customer view, linking profiles where people may have different names in different silos, linking data stored in different silos, and trying to produce a definitive overlay showing the true picture of the data within an organization. We've got numerous examples of this. We've got people who are using this within MDM products like Pitney Bowes. We've also got a very good use case at Cisco where it's used as it says here, to provide a single source of the truth for all of their internal and external hierarchies. Fraud detection. This is a very good graph use case. So just to quickly describe what we see in fraud detection. If you go into a bank, open a bank account, immediately go to the ATM outside and try and withdraw £1 million, the bank won't give you £1 million. It will probably take your card away, and an investigation will follow. So if you're committing a fraud, first of all, you want to avoid the most elementary checks. So you don't want to immediately open a bank account and try and withdraw a lot of money. What you do want to do, though, is to start to look as normal as possible. And looking normal is a bit of a pain in the neck, because it means you can't be an outlier who's detected by any of the bank's anti-fraud systems, and you need to do a bit of work to do that. Now, if you're going to do that, you need to open several bank accounts. Opening several bank accounts is a bit painful, because you have to produce evidence of identity, utility bills, and bank statements from previous banks and things like that to prove that you are who you say you are. Now, it's not very difficult to do that, but once you've done it, you still are limited with the amount that you can rob from the bank, because you don't want to look like you don't want to stand out and be an outlier. You still want to conduct normal banking transactions, and you're going to have to do that a lot of times if you're going to make a lot of money by defrauding the bank out of £20 or £30 a time. So you need to do that at scale. And remember, those identity tokens that you use to set up a bank account are hard to obtain, so you need to reuse those. So the way in which these frauds are often conducted is a lot of false bank accounts will be set up using the same identity tokens, and then money will be withdrawn from all of those bank accounts at once, and the fraudsters will disappear from sight. It's quite hard to detect that sort of behavior with most systems, but it's very easy with a graph, because that pattern of people opening bank accounts using the same identity tokens is a pattern in a graph that can be detected and acted on. So that's one of the ways in which Neo4j has been used for fraud or fraud detection. And as Gorga Sadowski says, it's capable of stopping advanced frauds in real time. We've got users like RIA, a money transfer agent. We've got some of the major credit card companies who are using Neo4j for exactly this sort of real-time fraud detection. And most famously, the Panama Papers story was revealed by linking all of the information in the stolen database that was stolen from the intermediary in Panama, and then using Neo4j to link together the identities and the activities of the customers of that intermediary to produce a paper trail that allowed, for example, the recognition that the Prime Minister of Iceland had a wife who was investing in some of the companies that he was bailing out through an anonymous company, and numerous other stories across the world. So that's a great use of a graph database. We're practically impossible using any other technology. Another use case is what we call graph-based search. Graph-based search is, you may be familiar with the concept of faceted search. If you go to a website, you're often invited to restrict your choice to, in the case of Amazon, to computer goods or to books or to movies. But a graph-based search is much more than that. It allows sort of multi-dimensional faceted search through the data that allows you to reach your destination much more quickly, even when there are lots of products that have got the same name or in other ways similar characteristics. Another, I should say, that's being used by quite a lot of companies in the search business, but it figures in unexpected places as well, such as Lufthansa, who are using it for in-flight entertainment. So you can search, do faceted, super faceted search to find the movies that you're interested in. Another very obvious, I guess, use case for Neo4j is just mirroring the complexity of networks, of physical computer networks, linking servers and routers and bridges, and all the other things you find. And the power of the graph is obviously that it allows arbitrary structures to be modeled very easily, but also it's very good at allowing you to express the different layers that you encounter. So here we've got physical assets, routers, etc. But on top of those, there will be services, there will be groups of customers, there'll be all sorts of logical layering in the data, and each layer depends on the one below it. And if you're trying to do, for example, root cause detection, or if you're trying to do impact analysis, you need to understand the links between the layers. And those can be very dynamic. We all know that using virtual hardware, applications can be moved without notification from server to server, which means if there's an outage, it's often quite difficult to work out what's going on. And that's where a graph, for example, can give you an instant, up-to-date impact analysis of an outage. That's being used both by Cisco, we've mentioned before, and HP, built into some of their components, so that some of the HP network management tools use Neo4j inside to provide network analysis, root cause analysis, and impact analysis. Okay, another very good use case is identity and access management. So this is where you, for example, have got, if you're a bank, you might have hundreds of users within a large organization. So if you're providing banking service for a multinational, you'll have dozens of people who are allowed to access your banking facilities from within that multinational, and you need to be very careful about which one has got the authority to do what limits there are, where you need to go to a dual signature, who has proxy rights to act on your bank account. Or it may be the same in personal banking for parents looking after their children's bank accounts. So who has access to what is often a very non-hierarchical, very rich network of connected data. And Neo4j is great for modeling that. UBS in London is using Neo4j for managing their customer access to their banking capabilities, and as you can see there, that's an award-winning application for UBS using Neo4j. Neo4j has been adopted by numerous different companies in numerous different financial verticals. This is just a small section. You'll see maybe a few companies you recognize. TomTom, the in-car navigation, Nomura, financial services, Adidas, they're using it for graph-based search and website management. LinkedIn are using it in China for providing a new service for using social marketing for people who've just left school or just left university in a first job stage where they don't have much in the way of a LinkedIn profile, and they need to be managed using social tools that work for that age group. Okay, so what is it that people are using graph database for? We've looked at the use cases, but why do they then stick with it? Why a graph? So there are a number of characteristics of a graph database that once you get into it become compelling. They're very intuitive, they're very fast, and they're very agile. And we'll look at each of these in turn. So here we see somebody who's thinking about a system design for the first time. And what do they do? And what do you do? And what do I do? We draw it. We try and draw some sort of picture. and very often we find that we're drawing blobs linked by lines. We're drawing a graph, and the beautiful thing, the amazing thing about Neo4j is that we store what you draw. So the structure on the database, in the database, is very direct representation of the business problem. It doesn't go through the conceptual and logical and physical design process. There's no point at which you with a relational databases typically denormalize the data in order to get better performance, which means that there's a big gap between the database as it's seen by the technical people and the database as it's seen by the business people. With Neo4j, the database is understood by everybody and is extremely intuitive, which gives great benefits in terms of getting the problems right first time and not having to do huge amounts of rework. Looking at speed, so we already looked at how Monsanto had used Neo4j because they couldn't analyze their crop generations quickly enough. But an even more powerful example was a company called Shuttle in London, which used Neo4j for calculating optimal delivery strategies for goods. In fact, they do same-hour delivery, and they were so successful that they were bought by eBay, and now this service is called eBay Now, and is providing same-hour delivery services all over the world. So there's the developers at eBay say minutes to milliseconds, and that's literally true. Very, very much faster using Neo4j. And finally, we'll look at agility. So we've already talked about the way in which the graph can evolve and adapt. As you extend the scope of your system, it's very easy to include more data, a more functional, more business concepts just by adding new elements to the graph. It's a very non-destructive way of doing things. There's no major refactoring required. So you can build complicated applications in a nice agile way without worrying that you've gone off in the wrong direction to start with and that you're going to have to rebuild your database completely after a few months. It's an extremely forgiving, evolving and adaptive model. The second thing that contributes to agility is the query language that we've developed with Neo4j. We've developed a language called Cypher, which is what's called a declarative language. So you don't need to worry with Cypher about how the data is organized. You ask a simple question using a simple language, which is as like SQL as we can make it, so it's familiar for people, but does have some special facilities for pattern matching. And it's a business level query that you design. So people do tend to fall in love with Cypher because it is so efficient. So what we're looking at here is a same problem using SQL with a relational database behind it, and using Neo4j with a graph, using Cypher with Neo4j behind it. So what this is trying to do is just to count the number of employees who report to a senior manager, and then grouped by the first level of manager. So if you look at that, you think, I'm not going to waste my time reading that. That looks frightening, and you imagine it's going to take a long time to debug. It's going to take a long time for anybody to understand if they need to make a change. And as the structure of the database changes, it has to be maintained. So it's a simple question that's resulted in a very complicated piece of logic. Looking at Neo4j, on the other hand, I don't know how much you in the audience know about Cypher, but it's pretty easy to see what's going on here. We're just doing a match, which is the Cypher equivalent of a select statement. We're just trying to find the boss and his subordinates and how many people those subordinates manage. So it's basically a 2-line query in Neo4j as against, I can't even count how many lines in SQL. So that has obvious impacts on your projects. You can write your queries more quickly. It's hard to. It's much easier to debug things, and most important, as far as TCO is concerned, cost of ownership is concerned, you don't need to. You don't become dependent on key project members in order to maintain the code going forward. It's understandable and it's maintainable and it's modifiable. Okay, as I was saying, users do, once people have spent an hour or two using Cypher, they often say they will never go back to Neo4j, go back to SQL again, because it's Cypher is such a natural way of looking at a natural model of the world, a model of things connected to other things with no intermediate concepts like artificial concepts like rows and tables and columns and so on, just things connected to things with a powerful language for getting at them. Okay, so that's been a pretty quick introduction to Cypher. I should say it's being adopted quite widely. We've created an open standard called OpenCypher, which is being used all over the place. We hope it will encourage a lot of front-end developers to develop new ways of displaying and interacting with Neo4j, but also inevitably it will create back-end developers competing directly with Neo, and we wish them luck. Okay, so we're almost at the end of this talk. I hope you've been intrigued, I hope you've been interested, and I hope you're now ready to have a go with Neo4j. So it couldn't be easier to get started. You can download the product. It doesn't take more than a few minutes on most internet connections. It's very easy to download, and when you download it, you'll quickly load the Neo4j browser, which has got a help guide with some example databases and access to all of the support information you need, so you can get started very quickly. On our website, you'll find the Graph Academy, which has got a list of classroom-based and online training facilities. And there's training happening in most cities once a month or so. There's one in London, I think, on the 22nd of November, an advanced Cypher course. There's one in Amsterdam, and there are other ones in other parts of Europe. Finally, if you want to learn more, you can look at our YouTube channel, where there's the latest and greatest announcements of the most recent release on Neo4j, but also a very large range of people who are showing how to do particular things or how they've solved their problems. Neo4j is an open source product. It's got a very large and active community, so you're very welcome to participate. So that's the end of what I had to talk about. I've now been joined by Jesus to answer any questions. So is there anybody in the audience who's got any questions?
I think we have one question, which is, how does Neo4j integrate with other elements in architectures, in other architecture? I don't really. Do you have an answer?
Can you answer that question, Jesus?
Sure. Yeah, of course. You can help me all right. Yeah, well, as Jonny has described, Neo4j is a data store. I mean, it's a very powerful data store, and as a data store, it can integrate with a number of components. And I would probably mention those that bring data into the store. That would be typically ETL tools, and well, there's a number of ways in which they can integrate. That can be JDBC based. That can be through the REST API, and the other category of elements in a standard data architecture would be the data consumers, and that can be BI tools, that can be visualizations, and again that can be through standard interfaces, or as well there's a number of of language drivers. I mean, if you decide to build your own visualization, for example, your own client application, there's a number of community drivers, but there's 4 of them that are part of the standard delivery of Neo and supported by Neo technology. And these are the JavaScript one, the Java one, of course, Python and .NET. So many different ways and what a simple component to integrate in your data architecture.
We have other questions. So we have a question that says, what are good tools for visualizing graph output? I know Neo4j comes with its own browser, but most of my customers use Tableau or BO.
Yeah, as I was mentioning, I mean, you may want to consume graph data and visualize it as a graph, and there are some commercial tools that can do that for you. We have partnership with some of them. One of them would be Linkurious, for example. But there are standard BI tools like the ones you mentioned, like Tableau, ClickView, or many others. And well, just to mention these 2, I mean, they typically access through the REST API. Through Tableau will use the web data connector component, so it's pretty straightforward. You can define through Cypher what's the data set that you want to extract out of Neo, and it's directly imported into Tableau, and you can do your standard visualization or even combine it with the data coming from other sources. So it's pretty straightforward.
Okay, we have other questions. Can you talk about the limitation of Neo4j? Under what circumstances would you suggest people not to use Neo4j?
Well, I mean, as Jonny has described, I mean, it uses a particular way of modeling data. So, I mean, you define the limits. I mean, there's not. I mean, the graph model, the property graph we've described, is really simple, but really rich and powerful, very expressive. So I can't think of a domain that you can't model using a graph database. Now, if you're coming back to what relational has been solving for many years, if your data is very predictable, if you get data through forms in a very structured way and you consume it to produce reports, then maybe you'll find with relational databases. But I mean, I can't name a domain that I would say don't use graphs in that case. I mean, of course, the key driver should be what's the value in the connections in your data. So we're seeing that data points are valuable, of course they are, but the connections between them are sometimes even more valuable. So if you detect that that's the case, then graphs can definitely help you.
Other question, is it possible to deploy a distributed version of Neo4j, like the traditional databases with partitions and read replicas?
You can deploy Neo in a clustered configuration. I mean, you can have multiple replicas of your data. Now, in the current version, you won't you can't do partitioning. I mean, each of the instances in a cluster will contain and will hold a full copy of your data. So that's the way it stands. But I mean, our experience is a very efficient storage, and it's I mean, I was going to say it's quite unusual. We haven't come across a case that Neo can't handle in terms of capacity or limitation of the storage in a single node. But yeah, you can deploy it in a cluster configuration for high availability, for disaster recovery, and to deal with high throughput. So that's definitely possible.
There's another question that asks, how many nodes can Neo4j handle?
Well, there used to be a number that I could say, which in up to version 2 point something, that was 32 billion. But when we released version 3 back in April, the limit was removed. I think it's in the beyond trillions, quadrillions. I don't know if you but basically it's unlimited in terms of the number of nodes.
Yeah.
That's it for the questions.
Okay, well, thank you everybody for joining today. We'll send an email with a link to the recording. Are we going to distribute the slides as well?
Yeah, we can send you the slides, and the webinar is going to be recorded and available online in the coming week. Thank you everyone, and have a very nice day. Bye.